In the name of God. Hello everyone, my name is Soheil Gheshlaghpoor. I'm Ph.D. student at the University of Tehran. We examine the relationship between a spatial pattern of green infrastructure and urban heat islands. Our case study was Tehran metropolis. For first step, the increase in temperature caused by urban heat island is effective in intensifying a wide range of negative environmental and social consequences. Urban heat island described the phenomenon of higher temperature in urban areas compared to the rural and suburban areas. One of the contemporary approaches to reduce the effect of urban heat island, increase air quality, and moderate climate change is a green infrastructure. Green spaces refer to the type of infrastructure related to the vegetation and natural elements. In this field, some studies emphasize that the class area or CA of green spaces had a negative relationship with the land surface temperature or LST, while they showed different results in the case of edge density, ED, and mean patch size, MPS. Our theoretical framework is based on, in the aforementioned studies, the same categories have been proposed for urban green spaces, and not much attention has been paid to the structure pattern of green spaces and their classification. Using studies conducted in this field in order to answer to the research questions, a conceptual model based on the relationship between the urban heat island and a spatial pattern of green spaces has been used to landscape ecology approach in Tehran metropolis. This research, with the aim of clarifying the effect of a spatial pattern of green spaces and their classification on the temperature of heat islands, is trying to answer this question. Number one, what is the relationship between the spatial pattern of green spaces and urban heat island? Number two, what is the role of different type of urban green spaces in land surface temperature change? In material method for classification of green spaces, we use local climate zone model and landscape metric based on satellite images. We use four metrics that are class area, mean patch size, edge density, and large patch index. Satellite image and NV 5.3 software were used to measure the LSC of Tehran. We use Pearson correlation and partial Pearson correlation for correlation between the spatial pattern and LST. And we use Landsat 8 OLI for estimating the green infrastructure metrics. Pearson correlation analysis in the study of relationship between the spatial composition of green spaces classes and LST showed that the spatial composition or CA metric of classes A, B, and D has a significant and negative correlation with LST, so that the highest negative relationship belong to the class B, scattered trees and green fields, and the lowest to the class A, that's mean dense trees and green fields. And in contrast to this negative correlation, the correlation coefficient of class C with land surface temperature is positive and significant. In relationship to the spatial configuration, the Pearson correlation of average size of each class of green spaces with the LST considered has a significant negative relationship. As I stated, the CA metric of green spaces spatial composition has a great impact on the configuration metric of these classes, so that this effect causes the correct correlation value of the configuration measured with the temperature not to be displayed. Therefore, by using a partial Pearson correlation coefficient and contouring the effect of CA metric, the relationship between configuration parameters and LSC changed a lot. In this way, metric of MPS, ED, LPI had a significant relationship with the classes A and B, B and C, A and D respectively. While before contouring the CA metric, almost all metrics have a significant correlation with the LSC. In discussion, investigating the correlation between the spatial composition of green space and the LSC showed that the area of classes A, B and D had the negative and inverse relationship with the LSD, which is similar to the result of previous researches. Class B has the highest negative correlation of the CA metric with the LSD, but it is not located in the main center of the city, which have a high temperatures. Class A, despite its spread in the east and center of the city, has a smallest area of the green spaces classes, and its CA metric has the least negative relationship with the LSD. Class D is located mostly in the south and west of the city, and its area has a negative relation with the LSD at the 99% confidence level. But it is worth mentioning that previous findings have shown that the effect of green spaces with a few trees and grass fields to reduce LSD, it is less than green spaces with the many trees. Thank you for your attention.